Hey everyone. Today we're going to be going over the ERC20 standard token demo that I did yesterday, Sunday, September 17th, at the Tampa Bay Blockchain Developers Meetup. I'm going to go over the same exact stuff. And if you want to see some more information, I'll go ahead or if you want to actually come to the meetups, you can. I'll put the link to the meetup in the description of the video, along with the link to our GitHub and everything else. So yeah, the ERC20 token standard. This is what allows arbitrary amounts of value to be put on top of the Ethereum blockchain. Most of these ICOs and tokens that you see today are actually part of the ERC20 standard. Some are a little bit more evolution, a little bit farther, different kinds of optimizations and security and things like that. But we're just going to go over the very basic version of it. And by having this standard, it allows exchanges and wallets to basically easily be able to add these tokens without too much work. Because if every single token has a different, framework skeleton that for sending and transferring everything, it makes it a little bit more difficult for developers to support these tokens. So on November 19th, 2015. This issue was opened to make it a lot easier for developers to support these things. As you can see here, there's 348 comments on this thread, and there's a lot of debate and conversation about the best way to do it. And actually, about 2 weeks ago, if you can see here, this was a draft, and about 2 weeks ago, it was officially accepted as an ERC20 standard by the Ethereum Foundation. So that's a pretty big deal. And yeah, let's get started. So the first thing I'm going to do here to create the Tampa Bay token is I'm going to make a couple state variables here, and they're going to be ERC20 state variables, and it's only 3 of them is all we need. And the first one is going to be a mapping, and it's going to be a mapping of addresses to a uint 256, and we're going to make this public and call it balances. So this is what's going to keep track of all the balances that have this token. The second one is going to be another mapping, and it's going to be of an address that maps to another mapping, another hash map, and it's going to be another address, and it's going to map to the value that that returns. It's going to be a uint 256, and what we're going to do here is we're going to make it public and call it allowances. And what this does is this gives another address, this second address, custodial access to transfer funds from your personal address. So basically, for example, if you don't want to put your private key onto an exchange, you would much rather actually just give them an allowance, so that way your funds are safe and there's nothing that can happen to it. They're just giving another account custodial access to transfer a certain amount of tokens, and that's it. So, and the last one is going to be a uint 256, and it's going to be public, and it's going to be called total supply, which is, I'm sure as you can guess, the total amount of tokens actually distributed or created. So that's it. Those are the basic variables that we need for the ERC20 state. Now there is another standard called the human standard that makes it a little bit easier for us to read what's going on. And you'll notice these, I'm sure. You'll recognize these. We're going to call it, so we're going to make string public name. We're going to do uint public decimals. And we're going to do string public symbol. And we're also going to do string public version. So now that we have that, we can actually, what we're going to do is we're going to hard code it here in the constructor function. But we also are missing one more thing, and that's a couple events. And these events get fired off when certain of the other functions that I'll put down later. But basically what these events do is allow for other, for example, web programs like which we would see on Etherscan to witness these transactions. So we're going to write event, and we're going to call it transfer. And we're going to do address, and we're also going to index them, which allows these to be searched for, that's really what the index does. It allows you to search for them. And we're going to do, oh, there we go. And we're going to call it from. We're going to do another address, and it's going to be indexed, and it's going to be 2. And we're going to do one more, and we're going to do uint256 with the value, just like that. And we're going to do one more event, and we're going to call it approval. And there's going to be an address, indexed, and instead of from, we're actually going to call this owner. And we're going to do another address, indexed, and we're going to call this spender, and also the value. So uint256 value. So every time a transfer occurs, when we call the transfer function, we're going to push this transfer event. And whenever someone is approved to transfer funds on the behalf of another address, we are also going to fire off this approval event. So yeah, now all we need to do is actually set up the variables here. We're just going to go ahead and hard code it. We can also put it in here so that it's dynamic, but we're just going to go ahead and hard code it here. So we're going to name equals Tampa Bay token, and we're going to do decimals. We'll do 18. And we'll do the symbol equals TBT. And we'll do the version equals 0.1. There's that. And also for the total supply, we'll set it to 1 million tokens. Just like that. And also we do need to set the balance to someone. So we're going to do balances, which has the mapping up there that I wrote, and the message.sender is the person actually creating this account, or this deploying this contract, and we will set it equal to the total supply, just like that. And just like that, if we were to deploy this, we would have a contract with 1,000 of this token, but we wouldn't be able to do anything with it because there aren't any transfer methods or anything like that. So with that said, now let's go ahead and write the skeleton of the methods that this is going to need. And it's 5 very, very simple methods. The first one is going to be called balance of, and this is going to take an address, and I'm just going to call it address, and it's going to be constant, returns, and it's going to return a balance. So uint256, and we're going to call it balance. And by making it constant, all this does is query the local copy of the blockchain on your computer, and it's free and instant. So it's nice to do that. So we'll do return balances, and we'll just pass in the address that is passed in when we call this method. So address. And that's it. That is the first one that we need. The second one is going to be function allowance. And the allowance is going to take in a address, and it's going to be with the owner, and it's going to take another address, and it's going to be with the spender, and it's going to return bool success. So the allowance is a very similar method to balance of. It's just a simple query. Actually, I need to put the constant here. It's just a simple query of our local copy of the blockchain, and all we're going to do is return the allowances of the owner and the spender, and that should return a value, just like that. Which you'll see in a function later when we do the approval function. You'll see exactly how this gets set. And real quick, let me get the other functions down here. So we'll do function transfer, and we need an address, and that's going to be who we're transferring to, and we just need a uint256 with the value, and it's going to return a bool, so we'll call it success as well. Leave that empty for now. Let's get the other functions done. Function. So this is the approve function when the approval event gets called as well, or gets pushed out. So with that, we're going to need an address, and it's going to be the spender. And all we need is a uint256 with the amount that's going to be allowed to be spent. So we'll call that value as well. And we're going to have returns bool success. And the last one, the last function for the ERC20 standard is going to be the transfer from. So function transfer from, and this is going to take an address, and you need to know where it's coming from, so we'll call it owner, and where it's going to, so call it to, and we also need the value, so uint256 value, and of course it's going to return a bool as well, so returns bool success. Okay, so now that we got the two simple queries out of the way, remember, when let's go ahead and do the let's do the basic transfer first before we get to the allowance and the approval and the transfer from. So just to do a basic transfer, all we need to do is we need to take the balances, and the person calling the method is the person who is sending the tokens. So message.sender, and all we need to do is minus equals and the value that is passed through the parameter or through the function. And that's it. And then to add it to the person who's receiving it, all we need to do is put the 2 and then plus equals and then the value right there. And here we're also going to call the transfer event. So it's coming from the message.sender, and it is, let's see here, going to is a parameter and with the value as well. So there we go. That's why it was a little wonky there. I've had a comma there. Okay, perfect. And now that that's called, all we need to do is return true. And that's it. Now for this function to really properly work, we do have to do a couple checks. The first one, we need to check if the sender actually has the balance of the tokens. So all you do is if balance is message.sender, which is the person who's sending the tokens, if their balance is less than the value being sent, then we are going to revert and exit out of the method. And there's one more check that we have to do. You're going to start to see this. It's pretty common. What happens is, because we're using uint256s, someone could actually send a absurdly large number and overload the memory and actually end up with a smaller number than originally your balance, the person being sent to has. So what we need to do is we need to check if balances of the person who's being sent the token plus the value being sent, if that is less than the total balances of the person who's being sent, which means that the memory was overflowed and somehow through the memory allocating, it actually is a number less than what was originally sent or than the balances, then we will go ahead and revert out of that. Just like that. And that's it. To do a simple transfer, that is all we need to do. So let's go ahead and do the approve function now. So this is going to give the approval of a spender you're going to approve someone to send a value on your behalf. So to do that, all we need to do is do allowances, and the address that the tokens are going to be coming from is the message.sender, which is the account calling this method, and the allowance, or the actual account that is allowed to spend it, is going to be the spender themselves. And that's it. And then you just set a value to it, or it's going to be equal to the value that's sent to that's sent through the method. So for example, if I approve account 1, or if I allow someone else to send 10 tokens and they send 5, and I do this allowance to check how much am I allowed to transfer, that is going to go, that's going to return 5. So I would need to, if I need to approve more tokens to be transferred, I need to go ahead and call this function again to increase it back to 10, for example, if I'm going to send 10 tokens. So there's the allowances, just set that, and the approval, I'll do that. And the owner is the message.sender, the person calling the method, and everything else stays the same. And then we're also going to return true. And that is it. And last but not least, the transfer from function is the actual method that's used by the custodial spender to spend on behalf of another account. So with that, all we need to do is do balances of the owner, and we're going to subtract the value. We're going to do the balances of the person being sent the token, which is 2. We'll do plus equals the value. And we also need to subtract the amount from the allowances. So we need to do allowances. One second. We need to do allowances, and it'll be the owner, and the person calling this method is the approved account. So it'll be message.sender. And we'll do a check to make sure that this is correct as well. And you just need to subtract the value from the allowances allotted. And since this is also a transfer, we do need to call the transfer event, and it's from message.sender. Transfer from, not message.sender, from the owner. And everything stays the same there. And we're also going to return true. So now we just need to do a couple checks, and that's very similar to the transfer up here. So if balances of owner is less than the value, which is the person whose token actually owns the tokens, if they have less, then we're going to go ahead and revert, just like that. And we're going to check for the overflow. So if balances of the person who is being sent the token plus the value is less than the total balances of the person being sent, then we're also going to revert. And we also need to make sure that they have enough allowance to be able to make the transfer as well. So if allowances of the owner, and the other key is going to be the person calling the method, so message.sender. If that is less than the value, we're just going to go ahead and revert as well. And that is it. Just so with that, we've actually created a very simple ERC20 token. Many of the newer versions have a lot more upgrades. For example, I'll go ahead and put links to the Mini-Me token, and there's the ERC23 as well, standard, and several others. So with that, let's go ahead and I've configured the deploy migration contract, and I've also configured our network here for the RINC-B testnet as well. So with that, let's go ahead and actually see if this compiles, first of all. So I wrote everything right. That doesn't make any sense, of course. I'm going to return a uint256, and we'll call this remaining. Of course, that did not make any sense. Okay, perfect. Okay, so we're just going to see if this compiles. Perfect. So let's go ahead and do a truffle, migrate, reset, and I'll do network RINC-B. And we'll go ahead and deploy. Oh, oops. Okay, so what we need to do is we need to unlock the account. So let's do, let me see here. I have this running for a while. All right. Let me get the IPC endpoint here. So we'll do geth attach IPC and then copy paste that. Perfect. So I'm gonna set equal the sender to eth.accounts 0, which is the account that I'm actually gonna be deploying this from. So I'm gonna do personal dot unlock account, put in the sender, put in my passphrase, unlocked. So now we can go ahead and migrate that. And we should be good. Perfect. Okay. So while this compiles, let me set a couple more variables. Let's set the receiver to be, let's get the second account from my eth.accounts. So we'll take the second one here. And we'll do receiver equals just like that. And let's set a value for when we send some money equals web3.2way 10, we'll call it ether. Okay, perfect. So with that, we've got the migrations contract getting deployed. And while this is finishing up, let's go ahead and take the code here so we can interact with the contract itself. Go here and let's get the interface so that we can actually interact with it. We'll do ABI equals, I'm just going to paste that interface that I just copied. I'm going to do set a contract variable, and it's going to be eth.contract. And we'll pass in the ABI. And we just need an instance to point to an address. So we'll do contract.at. And we've got our address for Tampa Bay token right here. Perfect. So now that we have an address, we have an instance, everything is good. Let's check the balance. Balance of sender is 1 million tokens, just like that. And let's check the balance of the receiver. Instance dot, actually I'll just go ahead and receiver 0. So if I want to do a transfer, instance dot transfer, we need to know who's going, where is it going to, which is the receiver, and let's do 10 as the value. And we also need to do from, since we're in the console here, and it'll be from the sender account. So with that, we submitted a transaction. Once that gets mined, we can actually check the balance, and should be good in one more block. There we go. So we've been able to transfer. No issues there. Everything's working. So now all we need to do is we actually need to list this on the Etherscan so we can actually look it up and see all the information. So Etherscan has a nice little thing here. Actually, we're going to use the Rinkeby Etherscan. And this is where you actually can see the blockchain code and everything. So I'm going to go ahead and grab the address of the token that was just deployed. And I made a transfer. So we're going to take a look at the contract code here. This a little bit bigger. And we want to verify and publish our source code. Now, because we're using Truffle, it's a little bit wonky. So we actually need to check out this new beta source code link here at the top. So we put in our contract address. We want to put in the Tampa Bay token contract name. Now to find the compiler version, all you need to do is come up here and do truffle version. and your compiler is this version of Solidity. So I'm running 0.4.11, and I'm going to go ahead and click. You don't want to click the nightly builds. You want to pick just the last commit is the only one you want to go with. So there's that. I'm going to copy paste the contract code here. So let's go get that code. Copied it, and there's that. And the last thing we need to do is set this runs optimizer to 0. And actually, I'll link on the description the thread where I found the answer to this. It's also in the GitHub as well, so you'll see it. And let's see if this works. Nice. So everything's good. We've got the contract address. And all of a sudden, we can actually see the code. Everything we need, including the ABI, everything. And if I were to go ahead and do the ERC20's token search for this contract address, and we just go in here, put this address, found it. So Tampa Bay token, total supply, and voila, we've got everything. So you can see the token holders, you can see where it's transferred, and you can also see everything. So that's it. That is the ERC20 token standard. I would like to do an ICO contract next, since I've already done the crowd sale one, we've done the ERC20 token. So we're going to go ahead and try to combine the two for the next one. Thank you very much.